Hello and welcome to another edition of Algebra 2 worksheets. We're going to be talking about some logarithms today. We want to remind ourselves, of course, of where logarithms come from first and foremost. So going over to a blank screen here, I'm going to remind ourselves that exponential functions are solved using logarithms. So for instance, if we have 3 to the x equals any number we want over here, 200, we would then say, well, let's apply a process to both sides. That process is log base 3. The reason we use base 3 is because the base of our exponent is 3. And once we do that, the log 3 and the 3 to the part kind of cancel out, if you will. And we're left with x equals log base 3 of 200. Now, the thing is, the reason this works is because exponential functions, exponential functions and logarithmic functions are inverses. As you'll recall, inverses are kind of opposite processes that cancel each other out. When you say that things cancel, you're basically referring to an inverse. I don't like to use the word opposite because that has the connotation of being like a negative, which works with plus and minus, but it doesn't really work when you talk about other things. So I want you to think about other inverses, multiply and divide, square and square root. If we use a log to undo an exponential, then what happens when we have a log and we need to undo it? What would we use? Logically, we would have to do the inverse to a logarithm, which is an exponential function. So what is the base of our logarithm? 4. What should the base of our exponential function be? 4. So we're going to exponentiate both sides. We're going to do 4 to the on both sides. And now, just like before, the 4 to the and the log base 4 will knock each other out. And the consequence is that we have x equals 4 to the 6th. So when we talk about writing these, this is logarithmic form, and this is exponential form. And this process here is how we go back and forth between them. So that's what we're going to be looking at. We're going to be addressing that. All right, back over to the worksheet now. So we need to address logarithms that have whatever base we want. I'm going to skip the first one and go to number 2 first. So number 2, we have a logarithm that we need to write in exponential form. So it means we need to undo the logarithm. To undo the logarithm, which is base 1,000, we're going to have to do 1,000 to the on both sides. So we write 1,000 to the log base 1,000 of 10 is equal to 1,000 to the 1/3. And the 1,000 to the log base 1,000 of is going to knock itself out, and we're left with 10 equals 1,000 to the 1/3. And that is our process. That's how we're going to do every single one of these. So now let's come back to number 1. What is the base of our logarithm here? It's a letter. It's z. All right, so it's a little less comforting. It's a little less comfortable, but we can do it. We'll just do z to the on both sides. So z to the log base z of s is equal to z to the 2nd. So, all right, let's remind ourselves once more, z to the log base z, those will cancel out. And what we're left with then is 5 equals z squared. And we're going to go through this process for every single one of these other ones. Now, you can see that there is a pattern. There is a pattern where we say, okay, well, the z is going to go here, and the s, oh, I wrote s instead of 5, but that's going to go here, and the 2 is going to go here. So you can just kind of follow through and be like, oh, this goes here and that goes there. I've been cautioning you not to do that. I've been saying that that is a terrible way to do this, that it is confusing, that you'll never remember what goes where in the long run, but it will get the job done. So if you're just interested in grinding through a worksheet, yeah, you can just put things in the places where they seem to go. However, what I'm going to contend is that remembering the process of applying to both sides and canceling is a much more reliable way of approaching these questions. So now we're going to scroll down. We're going to see what the rest of the sheet has in store for us. Rewrite in logarithmic form. Oh, well, that sounds familiar, doesn't it? We need to undo the exponential by doing a logarithm on both sides. What is the base of our exponent? M. So what do we need to do? We need to do log base m of the left side equals log base m of the right side. One of the most fundamental precepts of algebra, that you do whatever you want to one side as long as you do it to the other. And the log base m of m to the will cancel out. And so we're left with r equals log base m of 19/3. Similarly, if we have 1024 to the 1/5, we're going to need to do a log of a very large number, log 1024 of 1024 to the 1/5 is equal to 4. And we'll cancel. Shoop. Oh, I didn't write the other side. Hold on. Timeout. Timeout. Error. Error. You do need to write the log on both sides. There we go. That looks better. And so now we will bring everything down, and we will write it as 1/5 is equal to log base 1024 of 4. This is your process. And once again, like the above, you can do the this goes here, this goes there. So you can say, oh, well, the 1024 went here, and the 1/5 went here, and the 4 went over here. And you can do the hocus pocus, shuffle it around. See, can you follow which shell has the ball under it, sort of thing. But the process is much more reliable and will serve you better after the day that you're doing the homework assignment. Because even though all these questions you might be able to quick write down following along, oh, this goes here, this goes there, that won't help you understand, and that won't help you use this later. And yes, that is important. So these are a couple quick examples of how we would approach a conversion in the other direction. And now we have evaluate. Okay, so evaluate, that's going to be a case where we don't know what the value is, so we're going to try to solve it. Now, I've seen questions like this before, and they're always rigged to work out nicely. So even though we could type these into a calculator, you could just go to your calculator, hit log base, get log of box, logs base box of box equals, and put a 64 here and put an 8 here, and the calculator will then spit out an answer of 2. What is important here, you'll notice that the title of this sheet, which is partially obscured by my tag here, is the meaning of logarithms. So the intent here is to do these without the calculator, or at least not using the log feature on the calculator. So what we're going to do is we're going to go, well, we don't know what this is equal to, so let's just give it a name. Let's call it x. Now, if we call it x, we can rewrite this in exponential form and do 64 to the on both sides. And the 64 to the log base 64 cancels. And we end up with 8 equals 64 to the x, right? Why does this feel weird to me? Oh, I'm sorry, it's not 2. I wrote the wrong number. That would be if it was log base 8 of 64. Okay. So 8 equals 64 to the x. So how do we address this? Well, we make the bases match. So we say that 8 to the first is equal to 8 squared to the x. So 8 to the first is equal to 8 to the 2x. 1 equals 2x, and therefore x is equal to, not 2, but 1/2. So that's what I get for not actually typing it into the calculator and thinking I could eyeball it. Basically, what we are really asking is whatever the base is to the answer we want equals number inside. So in the case of number 3, that would read as 2 to the what equals 16. And if we go through the process of doing exactly what I just did, you're going to see exactly how that plays out. So we're going to do 2 to the on both sides. Or whoops, I need to write the other side first. 2 to the. So we don't know what it is, but we're going to cancel. And now we have 16 equals 2 to the x. And now we will make the bases match. 2 to the x is equal to 2 to the fourth, and therefore x equals 4. And if you come back to the statement I wrote here, 2 to the fourth equals 16, which it does, 2, 4, 8, 16. So that is how every single one of these is going to go. If the number on the base is bigger than the number that we are doing the log of, you're going to have a fraction. And if there is an actual fraction involved, the only way to get that is with a negative exponent, so the result will be a negative number. So let's illustrate that with number 4. So we're going to do, I don't know what this is, but it equals x. So we're going to do 4 to the on both sides. 4 to the log base 4 of 1 over 1024 is equal to 4 to the x. So 1 over 1024 is equal to 4 to the x. And then we got to figure out what 1024 is. That's the slightly trickier part. Now, I know that because I've done computer programming stuff, and I know that that's equal to 2 to the 10th. So because I know that, I'm going to write this as 2 squared to the x. It turns out you could do this with just 4s, because it's also equal to 4 to the 5th. But I happen to know this is 2 to the 10th, so I'm going to cut to that. All right, rewriting, this is 2 to the negative 10th, because we're taking it out of the bottom of the fraction. And 2 squared to the x by exponent properties is 2 to the 2x. So 2x equals negative 10, and x equals negative 5. As predicted, it is a negative answer. All right, so there is your process for trying to solve questions where you have any of these styles, whether it is the rewrite a log in exponential, rewrite an exponential as a log, or just simply evaluating a log. Now, I do have a second worksheet here we're going to talk about. And this one is a bit harder. So we need to address what the heck is going on here where it says condense. So we need to talk about log properties. Log properties are very difficult to get used to. Logarithm properties. So there are 3 main log properties. And they, unlike the log process that I've tried to encourage you to say, oh, this is just a thing we do to both sides, it's very intuitive. These are not nearly as intuitive. They're based on exponent properties, but being able to recognize how and why they work is not obvious. So this is a case where, yeah, you are probably just going to need to remember how this works. So the deal is, suppose we have some log of and we've got numbers on the inside that are multiplied. It turns out that this is the same thing as if we wanted to write two separate logarithms of that base with them added together and taking the two factors separately. So what we're going to take from this is that inside multiply equals outside add. Don't go the other way. It's very tempting to get this confused and go, oh, well, if there's an addition on the inside, I can do something with that. You can't. That doesn't work. All right, the second property is basically just a variation on that. It is m divided by n, and predictably, it's going to be the opposite of addition, since division is the opposite of multiplication, and so we're just going to subtract. So inside divide is equal to outside subtract. These two kind of work together. They're a pair. You know, if you understand the one, you should be able to understand the other. The third one is a little different, though. The third one says if you have some number to a power, that is the same thing as rewriting that same logarithm without the power, but then multiplying it by the power out front. So inside power equals outside coefficient. I'm not going to call it a multiply because that could lead to you confusing it with the first rule. I'm going to call it an outside coefficient. Now, you can go in either direction with these. It is not limited to going just left to right here. So there are going to be times when you're going to do one, there are times when you're going to do the other. Let's illustrate how they work, though. Let's suppose that I give you a messy looking expression like log of a to the 7th b to the 3rd over c squared. And this can be base whatever we want as long as we're consistent. I'm just going to write log and not worry about it. So it's common log, it's base 10 in this case. All right, so first thing we're going to do is we're going to recognize, well, we've got a times and we've got to divide it by here. We're going to break this apart. So I'm going to use property, well, first I'm going to use property number 2. What you're going to see is that actually I could have done a bunch of these at once. And if you see how this works, you can actually do it all in one big bite. But this is by property number 2. All I did was take the thing that's being divided and I said I'm going to write it as a subtract. Well, we still got the multiply up here to deal with, so I'm now going to write this as log of a to the 7th plus log of b to the 3rd, and then bring down the rest of it. And this is by property number 1. And then I'm going to say, but I got all these powers. Let's bring them out front. 7 log a plus 3 log b minus 2 log c. And this is by property number 3. So this is using all 3 of these properties in one Jagunda question. And this is the style that they will give you. Don't believe me? Look at the worksheet that we have here, this worksheet right here. They're going to take this. This is when it's not expanded, and we have to, or when it's expanded, we have to bring it together. This is the kind of question down here that I gave you, exactly as written. Okay, so let's come back over here to our blank sheet and talk about what about if we go the other direction. So if I were to give you 4 ln of a plus 1/2 ln b minus 6 ln c. Now I changed which base log it is. That doesn't matter. It's just log base e now, but that doesn't affect anything. ln is just a very specific logarithm. All right, so first thing I want to do, before I can combine these, I kind of need to have just lonely isolated logarithms. So we're going to bring these numbers inside using our property number 3, the power rule. So we're going to write this as ln of a to the 4th plus ln of b to the 1/2. Now b to the 1/2, let's remember that's the same thing as the square root of b minus ln of c to the sixth. So this is by property number 3. All right, then I've got an addition here. So let's bring that together. ln of a to the fourth square root of b minus ln of c to the sixth. That's by property number 1. That's by the add slash multiply rule. And now we've got to subtract on the outside. Outside subtract means inside divide. So we're going to divide that stuff on the inside. So it is ln of a to the fourth square root of b divided by c to the sixth by property number 2. And oh yeah, I should be dropping this down with equal signs. There we go. So this right here is your guideline to your log properties. You might want to screen cap that or set it off to the side because we're going to need that. We're going to need to make sure that we have these at our disposal and that we understand them. So I'm going to clear the screen now, and we're going to pop over to the worksheet. And we're going to see a couple of these in play. So number 1, it says condense each expression as a single logarithm. Well, that was the second example we did. We're going to bring our 15 inside as a power using property number 3. And we're going to do the same thing with the 3. And then we're going to recognize that we have an add on the outside of our logarithms. That's the same thing as if we multiplied the inside stuff. Doing the one right below it. Log base 5 of a squared plus log base 5 of b to the 10th. And then again, add on the outside means we're going to bring them together. Log base 5 of a squared b to the 10th on the inside of our logarithm. And that is how we write it as a single log. All right, to pick one more of these, I'm going to switch to one that has a subtract. So I'm going to do number 6. 6 log base 2 of u minus 5 log base 2 of v. Again, let's deal with the powers first. Log base 2 of u to the 6th minus log base 2 of v to the 5th. Now this is a subtract on the outside, which means we need to divide on the inside. So this is equal to log base 2 of u to the 6th over v to the 5th. All right, last one I'm going to look at is one of these ones that just has numbers. So I'm going to look at number 9. We're going to have log base 8 of 6 squared minus log base 8 of 5 to the 5th, which is the same thing as log base 8 of 6 squared over 5 to the 5th. Now, why am I doing this one as opposed to some of these others? Because we know what 6 squared is, and we can figure out what 5 to the 5th is if we're really determined. So this is log base 8 of 64 over 3,125. And so that's the answer I would give for that one. Yes, you should simplify numerical values. Don't do anything with the variables, of course. You don't know what they are. But this is how we're going to tackle anything that we have to condense. Obviously, the example that I gave you before was more complicated than these because it had 3 terms. It had like this minus log of whatever, whatever. So you can do this with a bazillion different terms if you want to. I'm not saying you ever actually want to, but if you're forced to confront such a situation, it can be done. All right, let's scroll down now to these ones at the bottom. Expand each logarithm. All right, I'm going to skip 11 and go to 12. So number 12, we've got a multiply on the inside. We have powers as well, but we'll deal with those second. So a multiply on the inside means that we need to add on the outside. So we're going to take the first thing that's inside, and then we're going to take the second thing that's inside, and we're going to add them together. And now we'll address these powers up here, and we'll say, oh, well, the 5 comes down as a coefficient, the 2 comes down as a coefficient. So it's 5 log base 4 of x plus 2 log base 4 of y. And this is what they mean when they say expand. They want you to do exactly what we did before in reverse. So for number 13, we're going to end up writing it as 2 log base 2 of x plus 5 log base 2 of y. And I just did both steps at once. Can you see how I got here? Let's keep in mind that I would have had an in-between step that would have looked like this. Log base 2 of x squared plus log base 2 of y to the fifth. So I got here by property number 1, and I got here by property number 3. Now, a couple of these questions in this section are a little weirder. So let's talk about number 11. There are two ways we could approach number 11. The first is we can say, well, the thing that is outermost that we have to deal with is this 3. So we could say this is 3 log base 9 of u squared over v. And then we could go through the properties with this. I'm going to say that that's the harder way to do it. So I'm going to go, nope, we're not going to do that. Instead, what we're going to do is we're going to simplify our expression first. We're going to say this is log base 9 of u to the 6th over v cubed. This makes a lot more sense to do. And this will be, the cube will apply to the inside and not the outside as long as there's not parentheses involved. If you saw something like this, the whole thing is cubed. Don't do what I'm about to do. In fact, don't do anything to it. Just say, yup, that's the way it is. But if we're cubing the guts of this logarithm, I think it's much more sensible to simplify the expression before we start trying to do stuff with it. So now we'll use log property 2, u to the 6th minus log 9 of v cubed. And then we'll use log property 3 and say that this is 6 log 9 of u minus 3 log base 9 of v. Similarly, I would write this one as x squared y to the 10th, and then approach it the same way. I would approach this one as u to the 24th over v to the 6th, and then use our properties from there. So if you need to contract and expand, this is going to be your roadmap. This is the idea. It's generally going to be that you're going to deal with the and subtract as a separate step from the bringing the power out as a coefficient or inside as a power. That rule property number 3 tends to be either the first or last step, depending on which direction we're going. So in the case of going this way, it's usually the last step. But if we are dealing with the stuff at the top here where we are condensing, it's usually the first step. So there is your method for condensing and expanding, and I think that should do it. So hopefully I've talked this to death and we don't need to go any further. Good luck, and I hope you do well.